Today we're going to be working on 4/8, so you're going to need out your 4/8 notes. Um, this kind of ties in really well with the quadratic formula. We're going to be using that in this section as well. So a nice formula for projectile motion here is h of t, that's the height of the object, is equal to negative 16t squared plus the initial velocity times the sine of the angle and all of that times t, and then plus h sub 0, which is the initial velocity. So that's kind of the formula. I'm just reading it from up there. Um, and again, we're looking at in terms of height and in terms in times of time, time there. And time is generally in seconds here, and then, well, it is in seconds here, and then height's there in terms of feet. So that's going to be the formula that we use over and over again here in 4/8 when we're looking at projectile motion of some kind of an object. So example 1 says, when a baseball player hits a ball, the bat propels a ball from a height of 3 feet at a speed of 150 feet per second and at an angle of 53 degrees. Write the equation to express the height of the ball as a function of time. So I'm going to kind of work through each of these parts here. Part A here, just to kind of give you a, before we start working at this, I'm going to kind of give you a picture here. So drawing out a little coordinate plane here. So basically what's happening here, from a height of 3 feet, so the ball is starting up here and shoots out and comes back down over here. So the ball goes up and then comes down. So we're supposed to write an equation to express the height of the ball as a function of time. So we're just going to go back to that other page over there, and it says h of t, or just our nice little formula there. We're going to plug everything in there. So h of t is equal to, it's a negative because the parabola is always going to be upside down over here, negative 16t squared plus v sub 0 times the sine of the angle, the whole thing times t plus h sub 0. So let's put our values in there. We're not gonna leave h of t, and we'll use t in there. But everything else should be filled in. So we got negative 16t squared plus, we've got an initial velocity up there. The speed is 150 feet per second times the sine of the angle, which is 53 degrees. We don't know what t is. That's going to be part of our formula there. And then you got a height there of 3 feet where it initially started there. So there's the equation there, and we could even clean that up. We could do 150 sine 53 there. And to do something like that, I'm going to have to make sure that my mode of my calculator is in degrees. So I'm going to double check that mode here. Mine's in radians, and I'm going to switch that into degrees. Got to hit enter. I'm going to do second quit here to get out of that. Alright, so if I put in my values there, 150 sine 53. So 150 sine 53. And I get about 119.8. So I'm going to plug that value in there. So h of t is equal to negative 16t squared plus 119.8t, and then plus 30. So I just kind of round that to the nearest tenth. Seems to be a good approximation there. So now let's look there at part B. Find when is the ball 59 feet above the ground? So 59 feet. Now, we're not exactly sure where it's going to occur. It could actually occur in 2 places. It could maybe occur 1 and 2. That could be 2 places, because when it's going up, it could be 59 feet. So looking over here at my little graph here, it could be 59 feet there, and then 59 feet over here in the other part. It could just be in one spot. Maybe 59 feet is way up here at the very tippy top there, at the vertex there. So we're not exactly sure where it is. So it says that when is the ball 59 feet above the ground? That's the height. So we're going to take 59 and we're going to plug it in for h of t. So 59 is equal to negative 16 t squared plus 119.8 t plus 3. And since it's a quadratic, we want to bring everything on one side. So I'm going to subtract 59, subtract 59. 0 equals negative 16t squared plus 119.8t minus 56. So now I can just plug that into the quadratic formula that we've been using. So t is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Well, if you remember this, our a here is negative 16. Our b here is what's in front of t, 119.8. And our c here is just our constant over here, which is negative 56. So let's plug those into the quadratic formula. So opposite of b there would be negative 119.8 plus or minus the square root of 119.8 squared minus 4 times a times c all over 2 times negative 16. So I'm going to plug that 119.8 squared minus 4 times negative 16 times negative 56 into my calculator here. So doing what's underneath the square root, just like we've been doing all along. Minus 4 times negative 16a 4 times a times c. And our c value there is negative 56. So coming over here, I'm going to write that value down. I get t equals negative 119.8 plus or minus the square root of 10,768.04. And I'm going to divide that by 2 times negative 16 there is negative 32. So now I'm just going to plug that into my calculator. I'm going to go negative 119.8 plus the square root of 10,768.04 divided by negative 32. And I'm getting about 0.5 to the nearest tenth. Remember, this is in seconds. So now I'm going to go the other way as well. I can say negative 119.8 minus the square root of 10,768.04. And I'm going to equals divided by negative 32. And 6.99, or about 7. Want to round to nearest tenth, it'd be 7 because that 8 would round that 9 up, so we might as well keep it consistent there and say 7 seconds. So there's two places, when we're going up in our little graph there and when we're coming down. So, you know, your graph is going and then coming back over here. So kind of draw a little graph here. So after 0.5 seconds, I don't know, maybe it's like right here. But then when it's coming down straight over here, it's also 57 feet above the ground. So two different places there. So you got two answers. So then we got part C here as well. So let's look at part C. find the maximum height of the ball and the time at which that was attained. So the maximum height of the ball, the max, occurs at the vertex. So the maximum height is going to occur up there at the tippy top there. So to find that, remember we got a nice formula for finding the vertex. We can say opposite of B all over 2A. Well, our B value, if you go back, and you got to go back to the original one, not the part C there, because part C is at 59 feet. So part A up there, your B value is 119.8. So that's negative 119.8. All divided by 2 times negative 16 was our A value up there. So this gives me negative 119.8 divided by negative 32. So I can plug that in. So negative 119.8 divided by negative 32. And I'm getting 3.7 about. We want the height, so we got to plug it back in there. So we got h of t is equal to, using part A's formula, negative 16 times 3.7. That's your t value, so you plug in 3.7 in for your t there. 3.7 squared plus 119.8 times 3.7. I'm getting this formula from part A here. And then plus 3, and I'm just putting a 3.7 in there for P. So when I end up plugging 3.7 in there, I end up getting 227.2 feet. Kind of keeping my rounding there to the nearest tenth. And then part D there asks, find the domain and the range. The domain and the range for our graph here. So it starts up here at 3. And then my vertex is up here, my ordered pair up here is 3.7 comma 227.2. And then when it lands over here in the ground, I'm going to have to figure out when it lands on the ground over there. So we did not talk about it landing on the ground. So when it lands on the ground, it's at 0 feet. So I'm going to put a 0 in for my height, equals negative 16t squared plus 119.8t plus 3. So if I were to use my quadratic formula on this, I would end up getting opposite of B, 119.8 plus or minus the square root of B squared minus 4 times A times C all over 2 times A here. So I'm going to plug that into my quadratic formula here, or into my calculator. So I've got negative 119.8 squared minus 4 times negative 16 times my C value of 3. I get 14,544.04. And I'm going to have to stop there pretty soon. So what I say, 14,544, right? 0.04. And then all over negative 32. So I'm going to stop her for now right there, and then we're going to continue the rest of it on the next video here.